Hi guys, it's Mrs. Tucker. Well, we're starting a new unit today. It's a huge unit for 8th grade math that, once you get the hang of it, it's pretty easy. And it's called Pythagorean theorem. It's a huge concept that everybody learns when they're in the 8th grade. But before we can talk about Pythagorean theorem, we need to talk about irrational numbers, because you're going to see a lot of irrational numbers when you do Pythagorean theorem, okay? So I want you to grab this little sheet right here, and we're going to start with stuff we know and then work into exactly what is an irrational number. So we're going to take some notes together. All right, the first thing I want you guys to do is fill out this perfect squares chart, okay? And I'm going to pause the video while you guys start filling this out. All right? All right, 1 squared, that's 1 times 1, that's 1. 2 squared, that means 2 times 2, that's 4. 3 squared, that means 3 times 3, that's 9. I know you guys know how to do all of this. 16, 25, 36. If I remember right, we gave you one of these on the first day of school, and you glued it into the front of your journal. You guys need to take out your journals and make sure you still have that, because you'll be using this a lot in the next week and a half. 81, 100, 121, 144. I know everybody's got their perfect squares memorized up to here, okay? You really need to memorize these next 3, and they're not too hard to memorize. The next one is 169. 14 squared is 196. It's real easy for me to memorize these because you just flip the 6 and the 9. It goes in numerical order, not 6, then 9, and then you flip them, 9, then 6. And this is 225. And you really want to memorize 15 squared because it shows up a lot. 15 times 15 is 225. And these are all called perfect squares. All right? We can think of perfect squares as the same as finding the area of a square. If I have this square here and it has a side length of 2 and a side length of 2, we know to calculate the area of a square, you're going to take the base times the height, which is going to be 2 times 2, which is 4. Now, if they tell you the area of the square is 4 and they want to know the side length, you're going to have to undo the squaring of this number. And how do you undo the squaring of a number? You take what's called the square root. You take the square root of 4, and it gets you back to the original 2 numbers you were multiplying together. Okay? Down here, what if I have a square that has a side length of 5 by 5? Well, 5 times 5 means this area is 25. What if I told you I have a square that has an area of 25, and I want to know the side length? Do you know what the big mistake is that kids do in the 8th grade? When I say you've got a square, its area is 25, what's its side length? They do that. And that's a huge mistake. If you take an area of 25 and divide it into 4 equal pieces, what you're doing is this. You're telling me the area of this one piece. I don't want to know the area of one of the pieces of that square. I want to know what the side length is. I want to know what number multiplied by itself gives me 25. So you're going to take the square root of 25. Don't do that. You might even put that on there on your notes and say, that's an error. Don't do that. I'm thinking kids do that because they think that with perimeter, you would divide by 4 to get the side length. Yes, you would. You would take the perimeter, divide by 4 to get side length. But don't take the area and divide by 4. That's only going to give you 1/4 of the area. Okay, how do you unsquare a number? You know, if I can take a number and add it, then to undo it, I subtract. If I can take a number and multiply it, then I can undo that operation by division. If I can take some number like, 5, and square it, the number that undoes that operation is called the square root. And it gets you back to where you started, okay? So it's like being given the area of a square and you want to find the side length. What is the square root of 25? You could think of this as the area of a square, which equals 25, and you're trying to find the length of each side of the square. You would take the square root of the area, and you'd find out that the side length is 5. All right. Let's find the square root of these perfect squares. This is the easy stuff. The square root of 4 means what number times itself gives you 4? Yeah, you know that's 2. Actually, the square root of 4 has 2 answers. It's 2 and what else? What other number multiplied by itself gives you 4 for an answer? Can you think of it? Yeah, it's going to be -2 because -2 times -2 also gives you +4. But we'll talk about that later. Oh, and by the way, I see a lot of kids do this in the 8th grade. They say, oh, the square root of 4 is 2 squared. And that is not correct. 2 squared is another name for 4. And the square root of 4 is not 4. It's not 2 squared. It's just 2. Okay? So, let's go on. The square root of 16, what number times itself gives you 16? Yeah, why don't you guys finish filling this out? I'll pause the video here. You finish filling it out. Okay, 7 times 7 is 49. Let's see, 9 times 9 is 81. 10 times 10 is 100. What number times itself gives you 144? What number times itself gives you 225? What number times itself gives you 196? What number times itself gives you 121? What number times itself gives you 169? What number times itself gives you 1? Okay, these answers are going to be fractions. What fraction multiplied by itself gives you 16 over 36? Well, in the numerator, what number times itself gives you 16? Yeah, that's going to be 4 times 4. What number times itself in the denominator gives you 36? Yep, that's going to be 6. So the answer to the square root of 16 over 36 is 4 over 6, and that reduces down to what? 2 over 3. Give these 3 a try. Let's see what you get. What fraction times itself gives you 25 over 100? Yeah, that's going to be 5 over 10. And of course, you know we're going to reduce. Right here, what number times itself gives you 9 over 64? Yeah, that's going to be 3 over what? And here, what fraction times itself gives you 4 over 25? 2 over 5. There you go. All right, moving on. Flip it over to the back side. What happens when a number's not a perfect square? Okay, let's say I have an area of a square. It looks like this, and all of the stuff on the inside, the area is 10, and I want to know the side length. Well, to find the side length, some number times itself gives you 10. You're going to take the square root of 10. And I know the square root of 10, if you guys go back and look at this, let's see, the square root of 16 gives you 4. The square root of 9 gives you 3. And in between those is the square root of 10. So I know the square root of 10 has to fall between 3 and 4. Okay? And when I use a calculator, I get 3.162 on and on and on. The number never terminates, which means it never ends, and it never repeats. Okay, the square root of 20. I know the square root of 16 equals 4, and I know the square root of 25 equals 5, so the square root of 20 falls between the two, so it's got to be between 4 and 5. So I want you to write 4 and 5. The square root lies between 4 and 5. And I've got my calculator handy, and the actual answer, if you plug it into your calculator, is 4.472135, on and on and on. The number never ends. We say it never terminates and it never repeats. Okay? Well, let's look at the square root of 40. I know the square root of 36 is 6, and I know the square root of 49 is 7, and the square root of 40 falls right in between those two. Somewhere in here is the square root of 40. So I know it's going to be between 6 and 7, and I've punched the square root of 40 into my calculator. And I got, let's see here, I got 6.324555532, on and on and on, and it never terminates and it never repeats. All right, let's try the next one. Let's say I've got a square with an area of 75. If I want to know the side length, I take the square root of 75. Okay, I've got the square root of 64 is 8, and I've got the square root of 81, which is 9. The square root of 75 falls between those two numbers. So it falls between 8 and 9. I'm going to punch it in my calculator. I'm going to take the square root of 75, and the calculator says it's 8.660254038, on and on and on, and it never does what, and it never does what? It never terminates and it never repeats. Okay? Here, if I've got an area of 110 and I want to know the side length, I'm taking the square root of that. The square root of 110 falls between the square root of 100, which is 10. What's the next whole number up? Yep, that's the square root of 121. So the square root of 110 falls between what two numbers? 10 and 11. I'm going to punch it in my calculator. Square root of 110 is 10.48808848, and the number never does what? And it never does what? That's right. It never terminates and it never repeats. I want you to shout it out the next time I ask, okay? Square root of 200. Well, let's see here. The square root of 200. I know that the square root of 14, because I just learned this, is what? 196. I know the square root of 225 is what? Oops. I'm doing this backwards. Oh my gosh, Mrs. Tucker, it's been a long day. Let's switch those around. 196 is 14. 225 is 15. Oh my gosh. So the square root of 200 has to fall between those two, right? So it's going to fall between 14 and 15. And I'm going to punch it in my calculator, and I get 14.14213562, on and on and on, and it never does what? And it never does what? You're right. It never terminates. That decimal never terminates and it never repeats. It never ends and it never repeats. What do you notice about the square roots of these numbers? Say it. There's two things you notice. They never what? You're right. They never terminate, which means they never end. They go on forever. They never terminate, and they never repeat. Okay, so let's finish this side up. Rational numbers. Rational numbers are numbers that can be changed into the ratio of two other numbers. For example, 5 is a rational number because it's the same as 5 divided by 1. It's a ratio of two other numbers. 0.5 is the same as what fraction? What ratio? Yeah, 1/2. I hope you guys have this one memorized. Carpenters use it all the time. 0.125 is the same as what fraction or what ratio? Anybody know? Yeah, it's 1/8. How about 0.875? Yeah, that's the same as 7/8. Okay, I hope you guys remember from the beginning of the year when we were doing fraction to decimal conversions, I showed you guys that 1/9 is 0.11111 and 2/9 is 0.22222 and 3/9 is 0.33333. So 0.1 repeating is 1/9, and that's the ratio of two numbers. How about 0.5 repeating? 0.55555 is what as a ratio? Yeah, that's 5/9. How about 0.8 repeating? 0.88888? Yeah, that's 8/9. Okay? Now, if I have 0.36 and it repeats, so it's 0.36363636, that's going to be 36 divided by 99. Okay, that ratio of those two numbers. Make a prediction. What do you think 0.123 repeating would be as a ratio of two other numbers or as a fraction? Make a prediction. Did you get 123 over 999? Is that what you got? Well, that's the correct answer. What about 0.02 repeating? 0.02020202. What do you think that ratio is going to be? Yeah, it's 2 divided by 99. Okay? Now, I've shown you, here we've got 0.82 and the 2 repeats. So it's 0.82222222. That's going to be 8/10 plus 2/90. Okay, and if you make this a denominator of 9, you've got 72/90 plus 2/90, which is 74/90. And I'm going to plug 74 divided by 90 into my calculator, and I get 0.822222. So using this kind of reasoning, what do you think that's going to be? 0.755555. What will that be as a ratio of two other numbers? The 7 is in the 10th place, plus we've got 5, and I'm thinking it looks like I should put that over 90. And I want 7/10 to be something over 90. Well, let's see, multiply by 9. 7 multiplied by 9 is 63. 63/90 plus 5/90 gives us 68/90. I'm going to take 68/90, put it in my calculator, and I get 0.755555555. Okay? The whole point of everything that we did just now, is to show you that whole numbers are rational numbers. Any number that terminates, it means it ends. 0.5, it ends. 0.125, it ends. 0.875, it ends. It terminates. They are also the ratio of two other numbers, the ratio of two other numbers. And repeating decimals, that's a repeater. That's a repeater. This repeats, this repeats, this repeats, that repeats, this part repeats, and this part repeats. All can be changed into the ratio of two other numbers. If it can be changed into the ratio of two other numbers, we call it a rational number. Well, if we've got rational numbers, then we have irrational numbers. Irrational numbers are numbers that cannot be changed into the ratio of two other numbers. All irrational numbers are non-terminating and non-repeating decimals, okay? All non-terminating and non-repeating decimals are irrational. Just like when we were taking the square root of 20. Square root of 20, and I'm going to use the symbol approximately equal to, the square root of 20 is approximately equal to 4.472135955 dot. It goes on forever. It never terminates and it never repeats, and we call this irrational. Anytime you take the square root of a number that's not a perfect square, you get an irrational number. Okay? All right. Moving on. Do you guys have a copy of this? This is a little cut and paste we're going to put in our journal. Okay? And it's called the real number system. The real number system consists of a set of rational numbers here and a set of irrational numbers here. All right, now let's start with rational numbers. And we're going to start with natural numbers. Okay, I'm a sheep herder and I've got sheep. And I'm an old sheep herder from a long time ago. And I went out and I counted my sheep. I've got 1, I've got 2, and I've got 3. Those counting numbers are natural numbers. So put in here 1, 2, 3, dot. It's all of your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So then the sheep herder decided, you know, I need to have a number that represents the absence of sheep. So he added the number what to this set? Yeah, he added 0, and we call those whole numbers. 0, 1, 2, 3, dot. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? Then the sheep herder said, you know what? I owe my buddy Joe a sheep. I am in debt to him 1 sheep. Or, you know, a couple months later, I'm in debt to him 3 sheep. I need to have numbers that represent the absence, the fact that I owe somebody sheep. So then we have our integers. And it goes like this, dot, -3, -2, -1, 0, 1, 2, 3, dot. All right, those are your integers. Okay, rational numbers now are the ratio of 2 other numbers. And we just saw earlier 5 is a rational number because 5 is the ratio of 5 over 1. We know our fractions like 1/2 is a rational number, the ratio of 2 other numbers. What about 2/5? Yeah, that's a rational number. Okay, what about 0.2 repeating? That's rational because 0.2 repeating is the ratio of 2 to 9. So all of your, let's put in 0.82 repeating, where the 2 just repeats. Those are rational numbers. Any number that terminates, any number that repeats, ratio of 2 numbers, you know, your whole numbers. And also, let's put in -3, because -3 is the ratio of -3 over 1, or it could be the ratio of 3 over -1. They both give you -3. Okay? Irrational numbers. Those are your numbers that never terminate and they never repeat. That'd be like the square root of 2. That would be like the square root of 10. That would be like the square root of, 64 is a perfect square. Let's say the square root of 65. Those are numbers that when you punch them in a calculator, they never terminate, they never repeat. Here's one that you ought to be familiar with, pi. You guys know that pi is approximately equal to 3.141592. It goes on and on and on, and it never terminates and it never repeats. Okay? Take this little guy and glue it in your journal. Now, you've got this worksheet, a little practice on estimating irrational numbers. Okay, I want you guys to go ahead and fill out this section up here, and I want to talk about this here. Well, you guys know that the square root of 144, what number times itself gives you 144? That's 12. But there's also another answer. What's the other answer? What's the other number when you multiply by itself you get negative 1 or positive 144? Yeah, that's going to be negative 12 multiplied by negative 12. Negative times negative is positive 144. So you really have two answers. So what we're doing here is, if I want the negative answer, I'm going to put the negative sign out front. If I want the positive square root, I'm not going to do that. So right here, the square root of 144, they want that answer right there. We're going to say 12. Okay? Which square root do they want on this one? What number times itself gives you 36? Well, 6 times 6 is 36, but negative 6 times negative 6 is also positive 36. Which one do they want here? They want the negative square root. So we're going to say that is negative 6. Okay, can you guys finish filling this out? Let's pause the video here. Okay, they want the positive square root of 196. That's going to be positive 14. They want the negative square root of 64. What'd you get? Yep, that's negative 8. What number times itself gives you 1 over 49? Yep, that's going to be 1/7, because 1/7 times 1/7 is 1 over 49. Right here they want the negative square root. What fraction times itself gives you 4 over 25? Yeah, that's 2/5. Negative 2/5 times negative 2/5 gives you this little positive 4/25 inside the little bar here. Okay? All right, now, without using a calculator, find each square root to the nearest tenth. And we have done this on our pre-algebra builders, so this should not be something new to you. I want to know approximately what is the square root of 7 is approximately equal to what number rounded to the tenths place. Okay, well, 1 squared is 1, and 2 squared is 4, and 3 squared is 9. So I know that the square root of 1 equals 1, and the square root of 4 equals 2, and the square root of 9 equals 3. Square root of 7 falls right in between these two. So 2 goes here, 3 goes here, 2 is the square root of 4, 3 is the square root of 9. Halfway in between 2 and 3 is 2.5. Is the square root of 7 closer to the square root of 4 or the square root of 9? Yeah, it's 3 away from 4, but it's 2 away from 9. Square root of 7 is somewhere in here. So now you can either do that guess and check thing, which I think a lot of kids prefer, you know, give me an estimate. Oh, let's try 2.7 times 2.7, all right? And I want you to multiply this out. Okay, I multiplied it out. You can see my work. I put in 2 decimal points. I got 7.29, but I'm looking for 7. So 2.7 was a little bit big. What am I going to try next? I'm looking for 7.00. And I know I'm not going to get exactly that. I'm going to try 2.6 times 2.6. Okay, pause the video. Let's see what you get. 36, that's 12, 13, 14, 15. Put in my little fake 0 there. That's 12 and 5. That's 6. That's 7. With 2 decimal places, I got 6.76. Which one of these two numbers is closest to 7? This one is 0.29 away, and the 0.76 is this one right here is 0.24 away. 7 is closer to which of these two? Yeah, it's closer to this one. So we're going to say the square root of 7 is approximately equal to 2.6, rounded to the tenths place. Okay? The other thing we can do is we know it's going to be 2 point something, and we can look at the fractional distance of this number to this number and this number to this number. Okay? 4 to 9 is a total of 5 units, and 4 to 7 is a total of 3 units. So it's about 2.6. Well, it just got cut off there. 2 3/5. 3/5 is the same as 0.6, so you get 2.6. Okay? I think that's kind of easy, but if you guys like guess and check, do whatever makes you happy. Okay, I want to do one more problem and I'll stop talking. A contractor needs to cut a piece of glass to fit a square window. All right, I have a square window. Yeah, that's the best I can do on making a square. Maybe it's not. Let me try my magical pen. Let's see if this will make a square for me. Bam. Okay. The area of the window is 12 feet squared. That's how many little squares, how many square feet are in here. First of all, what's the side length of the window to the nearest tenth of a foot? I want to know what's the side length. Okay? It's a square. They gave me the area, and I know to calculate area I have to take side times side, which is side squared. They gave me the area of 12. I want to know what number multiplied by itself gives me 12. Okay? And we normally write it like this. Well, how do you unsquare a number that's been squared? Yeah, you take the square root. So I know S has to be the square root of 12. Well, the square root of 12, that falls between the square root of 16, which is 4, and the square root of 9, which is 3. Halfway in between is 3.5. Let's see, 12 is 3 away from 9, but it's 4 away from 16. So the square root of 12 falls about in there somewhere, somewhere around 3.4. So I'm going to try 3.4 times 3.4. I'm going to multiply this out by hand, and when I did that I got 11.25. That's not quite 12, so I'm going to try, what am I going to try next? Yeah, I'm going to try 3.5 times 3.5. I'm going to multiply this out the long way, and I get 12.25. Which one is closer to 12? This one is 0.25 away from 12. This one's 0.75 away from 12. So I'm going to say the square root of 12 is approximately equal to what? 3.5. And that answers question A. They want to know part B, what is the perimeter of the window? Well, if this length's 3.5, and this length's 3.5, and this length's 3.5, and this length's 3.5, how do you find the perimeter? Yeah, you're going to take 3.5 and multiply by 4. Okay? Perimeter is the distance around. Don't forget, don't take the area and divide by 4. Never do that. That's never going to be side length. You guys are kind of thinking perimeter there, but okay, let's multiply this out. That's 12, 13, 14 with 1 decimal point. My perimeter is going to be 14 what? And I forgot my units here. 14 what? Yeah, that's 3.5 feet, and this is going to be 14 feet. You have 2 answers there. Okay? Good luck with this, guys.